So welcome everybody. We're doing independent living, section 1, finding a place to live, and we're going to just do example 4 today. So there are four learning targets for this lesson. Number 1 is I can calculate the affordability of monthly rent. That's what we did Monday. I can determine the relationship between square footage and monthly rent. That's what we did Tuesday. I can determine lease signing cost. That's what I did on the video on Wednesday that you can complete as async work. And then moving expenses is what we're going to start, I think, working on today. So we went over the vocab already. You want to put your name and those learning targets in there. Here's the video for example 1, where I review all the stuff we did on Monday. We did these warm-ups. We talked about example 1. And I think we went over these 2 Genesis problems. And then you were supposed to do these 2 problems, the Miriam problem and the Najalise problem on your own. If you don't know how to do those, go look at that video again, learn these techniques, all right? Here's the video for the example 2 on Tuesday at the class. So this was example 2. We had some data we entered in our calculator, and then we found the equation using our calculator. That was that line of best fit that goes through the scatter plot. We found that R value, and we were able to interpret both the equation and the R value. We did this question right here. So we said, based on this equation, what would be a good estimate for the amount of monthly rent charge for an 800 square foot apartment? I showed you how to do that one. You put in 800 in for X in the equation. You just substitute the 880 in for X, and then solve that. And then we had an answer. And then you had 2 problems to work on your own. All right. And then for Wednesday with the async work, we talked about lease signing costs. All right, all the different costs that go into signing a lease. I'm not going to talk too much about those today. There's a video where I talk about it. And the situation here was Rufus and Maria had an application deposit, and they had a security deposit, which was 1 month rent, and a credit report expense, and last month's rent, and the broker charged a 10% fee. How do you figure all this out? I went through all that. So you just add up all the different fees. And then we find there's a sum total of Rufus and Maria are going to have to pay like $6,924 before moving into this apartment. And then I had you work on these 2 problems here with Jan and Jordan. Jan and Jordan, just using the same techniques of Rufus and Maria, right? The problems I'm giving you to do on your own should be just like the ones we do in the example. So today we're doing moving costs, example 4. So whether you're renting or purchasing a home, you're going to need to budget for some moving expenses. When planning a move, you should consider all the options available to you. You can elect to have someone do all of the packing, loading, transporting, unloading, and unpacking for you, or you can do it all or part of it yourself with or without help from professionals. The cost of making a move depends on a variety of factors: how much of the work you choose to do, the distance you are moving, the weight and size of your belongings, how accessible the items are to the street level. Are you on the first floor? Are there many flights of stairs? Is there an elevator? And the location of pickup and drop off of your items. So these are just only a few of the factors that come into play when you are given a moving estimate. Many companies offer online services to help you. So here's the situation. Here's the example. Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he'll need more movers' time to pack, load, and unpack because his friends won't be able to help him. They'll be working on a weekday. Pardon me. If Jay moves on a weekend, he can probably get some friends to help him, which cuts down on the number of hours he will need to hire movers. Move Out is a moving company that supplies movers, trucks, and moving equipment. They have given him the following moving estimates. They give him an estimate. Okay, if you don't have anybody to help you, and if you want to move out on a Monday through Friday, it's going to cost you 6 hours of loading and unloading time, and then 5 hours of packing, unpacking time, which is we're going to quote you a cost that's going to be $720 you're going to owe us to help you out with this move. If you want to move on the weekend, you can get a friend to help. Well, if you're working, if that friend helps out, then you'll only need to need 4 hours of loading and unloading time for our movers. You'll only need 2 hours of packing, unpacking time for our movers. Therefore, we'll only charge you $400 total cost. So move out charges a set hourly moving team rate for loading and unloading and a different set of hourly moving team rate for packing and unpacking. Determine the move out hourly rates. Okay, here's kind of how you would do this. It's called systems of equations. All right, maybe you remember this from, this is an Algebra 1 topic. So this is something you should have had been familiar with from Algebra 1. To solve this problem, we have to set up a system of two equations. First, identify the variables to use. So in this case, we're just going to let X, we're just going to assign X to one of these things. Let X represent the hourly cost for loading and unloading. So we're going to assume Y. Let Y represent the hourly cost for packing and unpacking. So we end up with two different equations. So the situation here is we don't know what the cost of the loading or unloading is per hour, and we don't know what the cost of the packing and unpacking is per hour. So in order to solve this kind of equation, we're going to have two variables. We're going to have an X variable, that's the loading and unloading. We're going to have a Y variable, that's the packing and unpacking. If you have two variables in one equation, guess what? You can't solve it. You can't solve for two variables if you only have one equation. But if you have two equations, you can solve for two variables with using the systems of equations. And we do have two equations here. We have one equation, which is the weekday move, and we have another equation, which is the weekend move. Let's take a look at what the weekday move equation looks like. It's going to be 6 times X, which is the hours of loading or unloading, plus 5 times Y, which is the cost per hour of packing and unpacking. And we know that that's going to cost a total of, equal sign, it gives us an equation, $720. On the weekend move equation, we got 4 times X, again, loading and unloading, plus 2 hours of Y, packing and unpacking, equals $400. All right, so basically what they did is they took these descriptions, 6 hours of loading and unloading became 6X, plus 5 times Y, so 6X plus 5 times Y equals 720. That's how they came up with this equation. I got someone hit me up in the chat. What's going on? Okay, Zoom. Okay, Zoom, show me the chat. Okay, we have this. Yomari says she has the weekday move equation. Good. So here, so once we have these down, we can begin to graph the linear equations if you wanted to, right? We can go to our calculators with these equations. Let me get my face out of the way of this. There we go. To graph these linear equations, I'm going to turn on my calculator. Clear. All right, I can go to Y equals, and I can put in this equation, 6X. I'll put in the weekday equation. 6 times X, that's loading and unloading, plus 5. Oh, actually, you know what? I'm not going to be able to put this in because I have two variables. I'm going to have to hold off on that for a second until I get this far. I'll basically need to solve for the equation. I'll need to solve for the system before I can start putting these in to my calculator. So let's see how they did this. To graph the linear equations, first solve for Y. So what they're going to do is they're going to put each one of these equations in terms of Y. All right, that'll just make our life easier in the long run. So if we want to solve for it in terms of Y, we need to get Y by itself. So to get Y by itself over here, I see that I have 5 times Y plus 6 times X. I'm going to subtract 6X from both sides of my equation, which gets rid of it on this side, and it moves it over to this side. So this is what we have on the next line. We have 5Y equals negative 6X plus 720. Again, I want to get Y by itself. So I see it's being multiplied by 5. I'm going to divide by 5 on both sides of my equation. That gets rid of my 5 on one side of my equation, but now each piece of this gets divided by 5. So negative 6X divided by 5 just becomes the fraction 6 over 5 times X, or negative 6 over 5 times X. 720 divided by 5 is 144. So this is the first equation we can put in our calculator. Now we're going to get Y by itself over here. We're going to get Y by itself over here. To do that, we're going to have to move that 4X over to the other side. We're going to subtract 4X on both sides of this equation in order to get the 4X to move over. That leaves us with just 2Y minus the 4X plus 400. I need to get rid of that 2. I need to get rid of multiplying by 2 to undo multiplication by 2. I'm going to have to divide by 2. That's this next line here. 2 over 2 becomes 1. I can just ignore it. But now I have to divide this entire thing by 2. Well, negative 4X divided by 2 becomes negative 2X. 400 divided by 2 is 200. Now I can look at my calculator and put these equations in here. Let's see, I'll start with negative 6 divided by 5 times x plus 144. There's my first equation. Now I'm going to put in my second equation, negative 2 times x, that's what I'm doing right here, plus 200. All right, now I have two equations in my calculator. I can begin to graph. I can zoom, and let me see if I can zoom fit this. I'm going to try to zoom fit. That's less than ideal, but okay. Yeah, I didn't like that. Let me do zoom standard. And then I'll zoom out is what I'll do. So it's not going to show me anything because zoom standard has this thing. So let me just zoom out once I have it. All right. Zoom out. I want to zoom out like way over here as far as I can go. And that actually won't matter. You know what? Now that I think about it, I'm actually going to choose the window instead. This will be easier. Window. I want my x min to start at 0, right? That's where things start. I need my x value to go how far? I need to think about this. I need my x value to go from, let's see, how about 130? 130, or even 200. I'll do 200. I'm going to keep the scale to be 1. Or actually, you know what? I'll make the scale 10. That'll make it fit better. My y minimum, I'm going to choose 0. And I want it to go as high as, what was my highest y value? My highest y value might be 200. So I might do 250, just to go a little above that. What I'm trying to do is I'm trying to create a window in my calculator that will best display these two lines intersecting. That's what I'm trying to do here. Once I get that, let me try to press graph. Let's see what it does. Oh, it didn't like my window. Why don't you like my window? Let me try again. Let me try. I'll start at 1. I'll go to 130. I like the scale. I'm just going to copy the scale. Oh, I know why I didn't like what I did. Because I chose a bigger number for my y min than my y max. That's why it didn't like me. That's why it didn't like me. Let me try again. I want my y min to be 0. Actually, if I can, I'm going to stick with that 150. All right, now I'm liking it. I'm liking it now. Let me try again. Okay, great. I got one line there. I got another line there. Beautiful, beautiful. And what I need to do is I need to find out what is that, where do these two lines intersect? Where do these two lines intersect? Well, there's two ways to potentially do this. Let me show you the easy calculator way, and then we'll talk about the little bit harder doing it on paper kind of way. The easier calculator way is, let's see, second, let's use the second button, and you see how it says calc in blue? Calc in blue. We're going to second calc here. And do you see how choice number 5 here has intersect? Well, that's what we want. We want to find the intersection. So I'm going to say the first curve. I'm just going to press, in this case, all we need to do is really press enter. Enter. The second curve is enter. And I want the calculator to guess. I want the calculator to make a guess at where these intersect. So I'll press enter. And it will tell me what the x value is, 70, and the y value is 60. Look at that. As we're looking forward, the answers will be x is 70, y is 60. All right, that's how you can use the calculator to find this really easy. If you're going to do this the old-fashioned way, we're going to need to use a technique called either elimination or substitution. Do they even? You know what? This example doesn't even have you do elimination substitution, so I'm not going to show it to you. I'm going to have you do it one of two ways. I'm going to have you do this easy calculator way I just taught you, or I'm going to have you look at the table. I'm going to have you look at the table. And so what we're doing here is we're looking at the table. Oh, and I'm noticing my table. I'm going to change my table to 5s just to make life easy on me. No, I'll keep it right where it is right now. Sorry, I know I'm waffling here. What I'm looking for is when do these two y1 and y2 match? When do they match? When are the two y values the same? And I'm noticing that each one is they're both going down. They're both going down, but eventually they should meet somewhere. And I'm looking, yeah, so I know it should be around 70, right? Because I already figured that out at the intersection. So I'm looking for when, oh, see how they're getting closer? They're getting closer to each other. 68, they're getting closer to each other. 69, they're getting closer to each other. And at 70, look at that. Y1 and Y2 are the same value. Y1 and Y2 are the same value. That means these two lines, Y1 line and the Y2 line, both intersect when X is 70. Once I know that they intersect where X is 70, I can stick 70 in for X on either one of these equations and find out what the Y value is. For instance, I'll do this one because it's easier. 70 times -2 will be -140. -140 plus 20 is 6, I'm sorry, plus 200. -140 plus 200 is 60. So my Y value is 60. And if you plug in 70 in for X here, you'll also get 60 for Y. So that's how you will do this one. All right. That's kind of, we won't show you elimination substitution quite yet. Let's see. I've got two practice problems for us to work on. We move you, quotes James, for $1,170 for 8 hours of loading, unloading, and 6 hours of packing, unpacking. And we move you, quotes James, $840 for 6 hours of loading, unloading, and 4 hours of packing and unpacking. Write an equation that represents the situation for the weekday move. So I just want you to write an equation for the weekday move. What you're going to do is what we did right at this part right here where they did the equations. All right. Let me give you a minute to kind of think that through. The weekday move equation.
There's tricks if they, I guess the way that I would explain, because they don't have to like grab your calculator, is just tell them to opposite the X and divide by what's next to the Y. So I mean, it's just move one and fraction it up.
Okay.
So I mean, for a lot of them, we assume that they know that.
We only need an equation for this one, first one. You don't even need to put the equation in terms of Y yet. You just need an equation. Write an equation that represents the situation of the weekday move. Because this can be the hard part. If you can't build the equation, you can't solve this kind of problem. So you need to be able to look at a situation and be able to write an equation.
Is that the we move quote?
Yeah, the we move quotes James. We move you quotes James. We're writing an equation that represents the weekday move.
EX plus 6Y equals 1170.
That's all it is.
6Y equals 1170. Really is kind of simple. EX, 6Y. It's basic because you're going to give X and Y a characteristic. That makes this 6Y. 6Y. There's a 6Y. Thank you. Awesome. Thank you. Equals. Your eyes are not that bad. Not that old. 840. Okay, feel me? Now watch this. Now this is how simple this is. This is why I try not to over dramatize this.
Yeah.
So you move the X. So I tell them to just move the X. So what's opposite of positive X?
All they really need is those two equations
Yes.
for this. So the first part is it says weekday move is 8 hours of loading and unloading, 6 hours of packing and unpacking, $1,170 total cost. So it doesn't matter what variable you give this. We normally would do it like this. Normally, we'd say 8 times an unknown number, and we have an unknown number in math. We often call it X, plus 6 hours times an unknown number. We can't call this one X because it's something different. So we have to give it a different variable. Oftentimes we'll do Y. If you don't like X and Y, you can call it G and H, or you can call it R and T, or anything else you want to do. But generally speaking, we call it X and Y. And then it's going to be equal to 1,170. That's really all you need. If you want to already get going and put this in terms of y, you can begin thinking of this as like, oh, if I have to subtract 8x from both sides of the equation, I would have 6y on one side. I'd get rid of the 8x. I'd have negative 8x on the other side, because I remember I subtracted 8x from both sides. And I'd have plus 1,170. And then I'd have to divide by 6 on both sides of my equation, which gets rid of 6 here, which makes this 8 divided by 6, which makes this 1,170 divided by 6. And I don't know what that is off the top of my head. I'd go to my calculator and say, what is 170 divided by 6? And I can just use that number. 195. So this becomes 195. And then actually 8 divided by 6, I can reduce that fraction if I want. I actually don't need to, but I could reduce it, divide both sides by 2 and get 4 over 3, negative 4 over 3. So that's 2. But if you just put this part, you'd be fine. That's the weekday move. Now we got the weekend move. Now that you've seen the weekday move once, try the weekend move. Should be pretty easy. Yomari, you're awesome. Absolutely. Well done. Yomari's crushing it over here. She's like, well, it's going to be, obviously, it's going to be 6x plus 4y equals 840, right? Great. Now let's just to save ourselves a little bit of drama. We'll put it in terms of y right now. I'm going to subtract 6x on both sides, which is going to leave me with just 4y on one side of my equation, with a minus 6x on the other, plus 840. Okay, and now I need to get this 4, get rid of this 4. I'm going to divide by 4 on both sides of my equation. If I divide by 4 on this side of my equation, 4 goes away. But now I got to divide by 4 on each piece of the other part of the equation. That's divided by 4. And that's going to be divided by 4. I can go to my calculator and figure out what all this is. 840 divided by 4 becomes 210. All right, so that I can just substitute 210 in for that. And if I want, again, you don't need to simplify this fraction, because once you put it into y equals in your calculator will know exactly what to do with it. But I can divide by 2 on both sides and get this to be 3 over 2. So now I have 2 equations. Oh, life is good. I have 2 equations that are equal to y. Life is good. I can then put them in my calculator. Here I go. The first equation is going to be, remember, that's why I set this equal to y, so it makes it easier to put it in my calculator. Negative 3 divided by 2 times x. I'm going to need to do one of 2 things here. I'm either going to need to put this in parentheses, or I need to put the x times 3 in the beginning. So what I'm going to do is I'm going to insert a parentheses there. So I have my parentheses times x. So I could do it this way, or I could put the x right next to the 3 on the top of the divisor line. One of those 2 things has got to happen. I can't just put the x next to 2, otherwise it'll think it's 1 over x. And then I put the 210 in. That's my second equation. That's my weekend move that I figured out, that Yomari figured out. And I'm going to go to my weekday move. My weekday move is negative. I'll do it the other way this time. I'll do negative 4 times x, because x is on the top of this equation bar here, the divisor bar, sorry. Then divide by 3, negative 4 x divided by 3. And in that way, I don't need parentheses because I put the x on the top to begin with. Oh, and then what did I do? What was that crazy stuff? I must put sign something. 195. I'm going to just do a 0.0 so it covers up whatever else that was going on. All right. And if my window should already be set up for this. So I'm going to cross my fingers and hope that my window's pretty good. That looks pretty good. I like that. Wow, this is going to be this is tight. All right. I need to figure out where these 2 intersect. 2 different ways. One way is to press second. Calc is in blue. Second trace or second calc. Go over to intersect. Press enter once, twice, 3 times, 4 times, and it gives me the x and the y. X is 90, y is 75. If you don't remember how to do it that way, press second, go to the table, And remember, we're looking for when these two y values are the same. So they're not the same now. They're getting closer. Ooh, we're getting much closer. Much closer. They're getting there. It's getting close, people. Oh my gosh. When are they going to touch? What are they going to touch? Right? Oh, did they just miss? No, I'm getting closer. I'm getting closer. There it is. When x is 90, both y values, the first equation and the second equation, I put in my calculator, they both equal 75. So they touch where x is 90. And I just have to decide which one of these equations would I like to stick 90 into to find out what the y value is. I'll do this one. I'll do y equals -3 divided by 2x plus 210. So I remember 90. 90 is the x value where they're both the same. So I'm gonna press quit. I'm gonna press, let's see. I'm gonna do the parentheses thing again. -3 divided by 2, close parentheses, times x. Oh wait, no, x is 90 now, remember? X is 90, so I'm gonna stick in 90 in there. In for x, that's when these two equations meet, 210. What's my y value at 75? All right, so now I know, like, if it asks me a question like, it says, use system equation to find out how much we move charges per hour for loading and unloading. Okay, so I already know what this is. It's $90 for every hour of loading and unloading. How do I know that? Because I made the loading and unloading my x value, right? Each time we made loading and unloading our x value. We know that what the x value is in terms of solving the system equation, it was 90, right? We could go to our table and find that out. There's 90. 90 is where these two equations meet. That means my charges per hour of loading and unloading is $90. Remember, my y value was packing and unpacking. Oh, it doesn't even ask me to do packing and unpacking. If it asked me packing and unpacking, it would be 75. And I solved that by finding out what the y value is. And then also, you could also look at the table too, right? If you're looking at that table, if you know they both meet at where x is 90 and they're both 75, that means the y value for the intersection is also 75 for both of them. Woo. Okay, that is it. That is all we're doing today. Well, I mean, that's all I'm doing for today. You are going to do the move a lot quotes for Donald, where you're going to write an equation. That should be easy, right? Yomari's is killing this one. He's just doing great with this, write an equation. You'll have to put those equations equal to y, and then you will solve for what x and y equals, right? You'll find out, you'll say what they charge for loading and unloading. You'll say what they charge for packing and unpacking, and then you're done. Then you're done for today. All right, you got 4 questions to do. All right, I will stop the record. I will stop the share. Let me know if you have questions.